Oh, pre-calculus. It's back, yay, right? Last week we did talk about the law of sines. So if you weren't on the call last week, I know some of you were, some of you weren't. Make sure you go back and watch that and ask me if you have any questions. It's a little bit, it can get a little bit dicey as to how many different answers that you can get for your law of sines. So, like I said, if you haven't watched it, make sure you do that so you can kind of figure out what's going on with that. Today, we're going to do 6.2, which is the law of cosines. This one's a little bit more straightforward. So it's basically one of those sections where it's just super mathy. Like there's not a lot of tricks to it or figuring it out. It's just a lot of plugging it in and getting through the numbers. So, you know, that's not always fun, but it's pretty straightforward as to what we have to do. All right, so not to scroll too much for you guys, but last week we talked about the law of sines, okay? And the law of sines was a ratio that you could use to solve non-right triangles. So remember, up until chapter 4 and chapter 5, we did a ton of things with the unit circle, and that all revolved around having right triangles, right? And sine, cosine, and tangent, they work super well for right triangles. We can just either use a unit circle or a calculator, find the values. Easy peasy, right? But what happens if your triangle is not a right triangle? So we have an acute right triangle right here, an obtuse right triangle. We call these oblique triangles that are not right. And so we actually can use sine and cosine to help us solve these triangles and find the sides and angles, just like right triangles, but it just takes a little bit more work. So, again, last week we talked about how to use the law of sines. The law of sines works really well to give you a really geometry throwback for a minute. It works really well for angle, angle, side, or side, side, angle. So do you remember when we had triangles and they would either give you two angles and a side or two sides and an angle? And we had different theorems and postulates that have to do with that. But basically what I'm talking about is if you get a triangle like number 4, this is an angle, angle, side triangle, right? They've given you two angles that are next to each other and then a side that isn't in between the two. And so the law of sines works really well for triangles that are angle, angle, side. It also works well for triangles. I don't think I have one on here. So here's another angle, angle, side, angle, angle, side. All three of the pictures there are angle, angle, sides. It also works pretty well for triangles that are side, side, angle. So that means that it's side, side, angle. So that means like instead of having 40 here, you would have a number for B. So side, side, and an angle that's not in between the two. Remember? So side, side, angle means that angle isn't in between the two sides. If the angle was in between the two, it would be side, angle, side. And I'll show you a picture of that. I know I'm talking. So just to let you know, that's what the law of sines is good for. It's good for angle, angle, side, and side, side, angle. Well, good for other things too, but you know. All right, so then we're going to skip forward a little bit and we're going to talk about 6.2, right? So 6.2 is for side, side, side. You guys having geometry flashbacks? Like, no. So side, 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 remember, is when we give all three sides. Or for problems that are side, angle, side, we want to use the law of cosines. Okay, so let me just show you what that looks like. This number 2 would be a side, side, side problem, right? We are given all three sides and we need to solve all three angles. Number 6 is an example of a SAS, a side, angle, side. There's a side, the angle that is between those two sides, and then another side. All right, so this is a side, angle, side. Here we have a side, the angle that's in between it, and another side, side, angle, side. So that's when you know you've got this law of sines and law of cosines, and which one you use depends on which angles and sides they give you. Okay? Everybody just have a huge geometry flashback. Side, angle, side, 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 side. Right? It's all in there somewhere, right? Okay. So here's how the formulas work. Again, there's not a whole lot to them other than this is the formula and you're going to plug it in and work through the problem. Okay. And there's not too much homework that goes along with it because of that. So the law of sines, you'll see, looks sort of like a combination of the Pythagorean theorem plus this little extra part on the end. Okay, so we have, if you have a squared, that equals b squared plus c squared minus 2bc cosine of a. Okay, so what you'll notice is that there's 3 versions of this standard form of the law of cosines. If you are using the Pythagorean theorem for a right triangle, c squared is always your hypotenuse, right? But since we're talking about triangles where they're not a right triangle, we don't really have a hypotenuse. So we don't really know which side is A, B, and C. Hey, Greta. We don't really know which side is A, B, and C, so we have these formulas to help us out, right? There's 3 formulas that have to do with that. And the one that you use depends on, are you trying to use the cosine of A to solve? Or are you trying to use the cosine of B or C? So it kind of just depends which angle they give you, which one you're going to use, if that makes sense. There is an alternative form for each of these. So what they've done is they've taken this standard form and they've basically rewritten it so that instead of having a squared equal something, this is when you're trying to solve for a side. If you're trying to solve for an angle, they've solved the formula for you. So they've given it to you in 2 formats, which is nice. You don't have to, if you need to solve for the cosine of A, you don't have to sit there and rewrite this formula. You can just use this alternative form of that same equation. So you'll see basically what they did is they subtracted b squared and c squared from a squared. Then they divided by negative 2bc. And then all the signs flipped and you get this equation. Okay. So I think really what we got to do is just work through the problems. I mean, that's really what it is. It's just how do you use these formulas? And then there's one other area formula that I want to show you. So let me copy this. Okay. Make it a little smaller. It's a little crazy big here. Nope, that's not what I want to do. All right, guys. Let's see. Start over. Let me make it a little smaller. I know I'm not doing this the right way. There we go. Just don't want to take out my whole screen. Copy that. Open up Paint. There we go. Make this a little bigger. Okay, so let's do number 4 because it's got a nice picture. Okay, so number 4 is with the clipboard. It is a triangle. Establish that, right? We got a triangle. It is not definitely not a right triangle, right? This is an obtuse triangle because that one angle B is bigger, right? And so what I need to do is I messed that all up. Start over, just paste over the top. There we go. What I need to do is I basically want to solve the triangle. So again, flashbacks from geometry. If you want to solve a triangle, basically means find all the sides and all the angles. So this one we've been given all the sides, right? Well, we have to find all the angles. If this was a right triangle, it'd be super easy, but it's not. So we're going to have to use the law of sines or the law of cosines. In this case, I'm going to use my law of cosines because this is a side problem, right? They've given me 3 sides and I need to know an angle. So the first thing I want to do is just decide which angle I want to solve first. I think I'd like to solve for angle B because it's the big obtuse angle, so I know my answer should be bigger than 90 degrees. There's no rhyme or reason why I picked that. It's just that I think it would be fun. Okay, there's no particular one. So notice here, I'm solving for angle B. So I need to look at this. Do I want my formula to be in the standard form or the alternative form? And so I actually want my formula to be in the alternative form because I want to solve for angle B. Right? So if I can get the cosine of angle B equals some number, then I can figure out what that is. Okay, so what I'm going to do is I'm going to use this formula because I'm solving for B, and I'm going to use the alternative form because I want to know what B is. So I'm just going to write this down. The cosine of B equals a squared plus c squared minus b squared all over 2 times a times c. Right? So the little letters represent the side lengths, right? So this is how it actually works. So the so this is angle B. So side B is actually the side that is across from angle B. You see that? So because angle B is over here, side B is the one that's across from that. And this is how it works in the law of sines too. Okay? So that means that side A is the one that is across from A. So that means A equals 4.2. And side C is the one that's across from angle C. So that means little c is 2.1. So then this just becomes a plug and chug, right? So we have 4.2 is A, 4.2 squared plus 2.1 squared minus 5.4 squared, all divided by 2 times A, which is 4.2, times C, which is 2.1. Okay. I personally just like to plug this into a calculator. You can do it step by step. Did I close? Give me a second. I don't know if I closed Desmos or what. All right. Oh, see my junk mail there. Desmos. Oh. Okay. Well, you guys all know how to use your graphing calculator, but let's just pull it up on here. Okay, so start graphing. I want more of that. Okay. So I really don't even need a graphing calculator. I just really need my calculator here. So I have 4.2 squared, right, plus 2.1 squared minus 5.4 squared. Okay, and then this whole thing is divided by 2, I can talk or type, 2 times 4.2 times 2.1. Did I do that right? 4.2 squared plus 2.1 squared minus 5.4 squared times da, da, da. Okay, so I get a negative number. What I like to do is I can write this down, right? I agree that the cosine of B equals negative 0.4, blah, 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 right? But what I like to do is I know that that's my value. But to solve for b, right, I'm going to have to take the inverse cosine of the cosine, again, geometry stuff, right, of both sides. So what I'm going to do is I'm going to go ahead and take my whole Desmos value here, and way out front, let's see if it'll let me, I'm going to go ahead and take the inverse cosine of everything. I need to make this bigger. You guys following along okay what I'm doing? I'm just going to like take the whole decimal out of the equation. There we go. Okay, so I got 1.95, whatever. No, I didn't just do that. Okay, good. Whew, forgot there was an undo button. All right, so I get this, right? Is that right? Well, it's right if I'm in radians, but remember Desmos defaults to radians. So I need to change to degrees and make sure if you're using your graphing calculator, you're back to degrees because we spent so much time in radians. Now we're back to degrees, right? And I get that B equals 113.76 degrees. So basically 113.8 degrees. Okay, so B is, after all of this work, B is 113.8 degrees. Okay, so did that, I'm pulling this back up so I can see the chat. Does that make sense, what I just did there? How mathematically I got to that number?
Yeah.
Cool. Mackenzie, Sarah, Greta, you guys good with that? Yep. Cool. Awesome. All right, so then now I know what angle B is, 113.8 degrees. I think Greta just buzzed me. Cool. All right. Now I need to keep solving my equation. Guess how I get to find A or C? Same exact way, right? So which one do you guys want to do? Let's do angle A, right? Angle A, no, let's do C. C should be our littlest one because C is across from our littlest side. So let's solve for angle C. So it's the cosine of angle C equals A squared plus B squared minus C squared over 2AB. Then it just becomes a plug-in problem, right? A squared is 4.2 squared plus B squared, which is 5.4 squared, minus 2.1 squared over 2 times 4.2 times 5.4. So again, you're going to solve this